Hi everybody, I'm Marianne Vogel. I'm a PhD student in Côte-Tutelle with the French and the Quebec. And today I'm going to talk about the first step of vegetation on the paleo-island of the proglacial Lake Ojibway. So first, a bit of context. As you might know, at the beginning of the Holocene, the ice from the North Hemisphere was melting. And so, it liberated the landscape that became available for the plant colonization. And sometimes when the ice melts, the water accumulates and it creates proglacial lake. That's the case in Québec, Ontario, where the Lake Ojibway covered the region of Abitibi-Témiscamingue until 8,200 years ago. And this lake it's a large area of water, as you can see. And so it has limited or restrained the plant colonization of this area. But the paleoecological studies of this area showed a fast arrival of the spruce species and a rapid migration rate. And so, it's a rapid migration rate that is even faster than what was expected. That is called the paradox of Reed. Fortunately, we have found the answer because on the Lake Ojibway, there were some islands. And in my first chapter of my PhD, we proved that the paleo-island could have acted as migratory outpost. It means that when the Lake Ojibway was still present, the paleo-island was already colonized by the vegetation that is coming from the south, where the lake was already gone. And it's a beautiful example of the range expression that Guillaume was talking before. And so, because they were colonized before the retreat, the drainage of the Lake Ojibway, they could explain the fast migration rates observed. But there is still some question we didn't answer, such as what was the vegetation dynamics on these paleo-islands, and if we can find some patterns or some factors that can explain this afforestation. So that's to answer this question, we studied paleo-islands from Abitibi, especially the lake sediment, and we selected lakes that are on such paleo-islands, which correspond to the top of the actual hills. And today I'm just going to talk about Lake Ojibway here, because I don't have time for more. So we performed a multi-proxy analysis with macro remains, pollen, charcoal, alpharix, and soon DNA. But today, so let's talk about the local vegetation. So we use plant macro remains. And here are my results. As we can see, we can identify 3 zones. The first corresponds to an open forest landscape because we found some Laurentide, some boreal, and also some biophytes. And it was followed around after 9,200 years by a diversification of trees and shrubs. And then after the drainage of Lake Ojibway, we found a boreal-mixedwood apparently dominated by Picea mariana, Pinus banksiana, and Betula papyrifera. So we also looked at the pollen dynamics to have a broader scale, at a regional scale of the vegetation. And in the first zone, we also found an open landscape characterized by long dispersal species maximum like Pinus banksiana and Elophilus taxon based on Elophilus taxon like Juniperus communis. We identified the pollen grain as Juniperus. And so there is also herbs and pollen concentrations that are maximum. And so this open landscape was followed after 9,300 years ago by the decrease of Pinus and Picea, and also around 9,200 years ago by an increase of Anus and Betula, as you can see here. And after that, it was mostly a boreal-mixedwood dominated by the Picea mariana, Pinus banksiana, and Betula papyrifera. So we consider this zone as the afforestation stage, followed by a densification, and that end up in a mature boreal-mixed forest that correspond to the actual biome. So again, we can find the steps that Guillaume was mentioning before, the afforestation and densification, maybe something like that. And if we compare the proxy, because that's the point of a multi-proxy analysis, is to have a better view of our data. So here you have the pollen or pollen diagram with in red the macro remains occurrence we find for the respective species. And it's for some species we have a better integration. It was easy because, for example, Betula papyrifera and Anus, when the pollen increased, we found the macro remains at the same time. So it supports the idea that just before that time it was a regional signal we registered in our pollen. But for other species, it's a bit more complex interpretation, like for example for the Pinus and Piscia mariana, for which when we found macro-remains when the pollen was decreasing, so it's a bit counterintuitive, but our hypothesis is that it's a proof of a forest that was closing, because the more trees, local trees there is, the more macro-remains we found, and the less pollen from the area can reach the spot we sampled. But it's an hypothesis. So we also looked at other proxy. Yes, we also looked at the diversity and we use the hill number M2, but you cannot see, but it's N2, to infer the diversity. And you can see that there is a peak around 9,200 kbp. And after that peak, we have opposite signal that when the pollen diversity is increasing, the macro-remains diversity is decreasing, for example, and we possibly it. And it shows the report complementarity of the proxies. And after that, we also have, thanks to the XRF scanning, the lithogenic element variation, which can be linked to the erosion. And so we see stabilization and a low erosion after 9,200 kbp. And we also looked at the fire dynamics thanks to the charcoal particles. And we have reconstructed, we have documented the fire events thanks to chair analysis with the triangles here. The Lake Perche, which I'm talking about, is in blue. And we use the CST method to detect the local fire events, sorry. And for Lake Perche, we have 3 events here, and here. And the first one is of a high magnitude fire, and the two others are smaller fire. And so if we look at all these corresponding proxy, what link can we see? Well, for some peak of the fire, we can see there is an increase. For the first fire, for example, we have an increase of the Pinus pollen. And we also have an increase of Betula pollen after this fire, plus some diversity of peaks that follow the fire. It is the same for the other fire, but we also find like macro remains. So we have a link between the fire and the vegetation diversity. But then another interesting fact is that we suppose that thanks to the high magnitude local fire we found around 9,200 years, it allows an openness in the forest that makes the establishment of Piscia and Betula and Aristocina possible. At the same time, the erosion was low. So yeah, that's it. We have an answer for our question. Like the Paleoislands were probably the source of the spruce trees that colonized the lowland liberated after the proglacial Lake Ojibway drained. And we have a link between the fire and diversity dynamics. And it seems like the high altitude fire have triggered the diversification of trees. Thank you for your attention.